Which of the following is not a valid activation function for the MLP classifier in scikit-learn? A. Logistic function. B. ReLU function. C. tanh function. D. Linear function. A. Logistic function. The logistic function is a valid activation function for the MLP classifier. It squashes the output to a range between 0 and 1, making it suitable for binary classification tasks. False. B. ReLU function. The ReLU function is also a valid activation function. It outputs the input directly for positive values and 0 for negative values, making it efficient in avoiding vanishing gradients. False. C. tanh function. The tanh function is another valid activation function. It outputs values between -1 and 1, making it useful for tasks where a range of outputs is desired. False. D. Linear function. The linear function is not a valid activation function for the MLP classifier in scikit-learn. It doesn't introduce nonlinearity, which is crucial for neural networks to learn complex patterns. True. D. Linear function. LTH3GT activation functions. LTH3GT LTPGT activation functions introduce nonlinearity into neural networks, enabling them to learn complex patterns. Examples include LTPGT LTUF TLTLIGT. Logistic function produces outputs between 0 and 1. LTLIGT LTLIGT ReLU function outputs the input directly for positive values and 0 for negative values. LTLIGT LTLIGT TANH function outputs values between -1 and 1. LTLI linear function outputs the input directly. This is not typically used in hidden layers of neural networks. LTLIGT LTULGT activation functions are essential components of neural networks. They introduce nonlinearity, allowing the network to learn complex relationships in the data. Different activation functions have different properties, making them suitable for specific tasks. For instance, logistic function useful for binary classification tasks as it produces outputs between 0 and 1, representing probabilities. ReLU function popular for its efficiency in avoidance of vanishing gradients, which is a common problem in deep neural networks. tanh function similar to the logistic function but outputs values between -1 and 1, making it suitable for tasks with a wider range of outputs. Linear function not typically used in hidden layers of neural networks as it doesn't introduce non-linearity. Let's consider a scenario where we want to predict whether a customer will click on an advertisement. We can use a neural network with the logistic function as the activation function in the final layer. The output of the network will be a probability between 0 and 1, representing the likelihood of the customer clicking on the advertisement. Let's say the input to a neuron is 2.5. Using the ReLU activation function, the output will be 2.5 since it's positive. However, if the input is -1.2, the output will be 0 since it's negative. LTH3GT neural networks. LTH3GT LTPGT neural networks are a type of machine learning model inspired by the structure of the human brain. They are composed of layers of interconnected nodes, neurons. LTPGT neural networks are a powerful type of machine learning model inspired by the human brain. They consist of interconnected nodes, called neurons, organized in layers. These layers are interconnected, and information flows between them through weighted connections. The process of learning in a neural network involves adjusting these weights to minimize the error between predicted and actual outputs. Imagine a system that identifies different types of animals in images. A neural network can be trained on a dataset of images labeled with animal types. It learns to recognize patterns and features associated with each animal, allowing it to accurately classify new images. Consider a simple neural network with two input neurons, one hidden neuron, and one output neuron. The weights connecting these neurons can be represented as a matrix. The network learns by adjusting these weights based on the training data. LTH3GTSCIKIT Learn LTH3GT LTPGTSCIKIT Learn is a popular Python library for machine learning, offering a variety of algorithms including neural networks. LTPGT MLP classifier is a class in scikit-learn for implementing multi-layer perceptrons, a type of neural network. For classification tasks, LTPGT. Scikit-learn is a widely used Python library for machine learning. It provides a comprehensive set of tools for various machine learning tasks, including classification, regression, clustering, and dimensionality reduction. Scikit-learn also offers implementations of various neural network architectures, including the MLP classifier for classification. Suppose we have a dataset of customer purchase history and we want to predict which customers are likely to stop using a service. We can use scikit-learn's MLP classifier to build a neural network that analyzes customer data and identifies patterns related to churn behavior. In scikit-learn, you can create an MLP classifier object and specify parameters such as the number of hidden layers, the activation function, and the solver used for optimization. LTLTLIGT Image Classification LTLI Natural Language Processing NLP LTLIGT Time Series Forecasting LTLI Fraud Detection LTLI Customer Segmentation LTLI. Neural networks have a wide range of applications across various domains. Some common use cases include image classification, identifying objects and scenes in images, natural language processing NLP, understanding and generating human language, including tasks like machine translation and sentiment analysis, time series forecasting, predicting future values based on historical data, such as stock prices or weather patterns, fraud detection, identifying fraudulent transactions in financial systems, customer segmentation, grouping customers based on their behavior and characteristics. Imagine a system for detecting fraudulent credit card transactions. A neural network trained on historical data can analyze transaction patterns and identify suspicious transactions, potentially preventing financial losses. Not applicable.